Hello, good evening.
Good evening, sir.
Good evening, sir.
Yeah, today we will cover week 11 content. Mm, Okay, let me share my screen. Okay, so is my screen visible? Oh,
Yes, sir.
thank you. Okay, so in week 11, there are four kind of discrete random variables, right? So we are covering discrete random variable, right? And you would have gone through that something like how to find expectation of a random variable, how to find variance of a random variable, let's say random variable x. So now we will see what there are some specific type of random variables when they can occur. So how you can deal with them in exam if a question is there, how do you know which kind of random variable is there? So if you know that this kind of random variable is there, it makes easy to solve the question as well as like you can use it in like real life. Okay. So there are four which are in week 11. One is Bernoulli random variable. Second is binomial. Third is hypergeometric. And fourth is Poisson random variable. Right? So this four type of random variables are there, which we'll cover today. Okay. So let's start with the first one, which is Bernoulli. Okay. So what happens is when we do experiment, okay, uh, and there is a chance of happening something success. So there are two possibilities only. Okay, so some experiment is there. Okay, and like we write sample space, right? Sample space. Let's say it could have anything values like anything, right? But when we define event or something like that, then we have to say what is successful event. Okay, success as an event and what is a failure as an event. If you do this, then it will become a Bernoulli trial, right? So for example, let's say tossing a coin, right? So let's say tossing a coin is a experiment, right? So what you get is a sample space is head or a tail, right? So if you define, let's say getting a head is a success, right? So you can say this is a success, and this will become automatically a failure because we are two only, so it will become failure, right? Let's say if we have rolling a die, right? So rolling a die, then if you write a sample space, it will be like 1, 2, 3, 4, 5, and 6, right? So in this, like we have 6 outcomes, but now we have to define what is success and a failure. So something we can define. Let's say getting a 6 is a success, right? So success is getting a 6. Okay. So this is a success, and not getting a 6 is a failure, right? Is a failure. So this kind of things, if we have where an event is there and where success and failure are defined very greatly, like then you can say that they are Bernoulli trial. Okay, and it happens once only. So when we do this event once, will not repeat this thing. Then then only it will become Bernoulli. So we'll see what happens if we repeat. So without repetition, like there is once will do it, and that's what makes it a Bernoulli trial. Okay, So like this. Okay. So yeah. So this is a Bernoulli trial, and what we do is we uh, let's say uh, let's say uh, a match is there. Okay. So some kind of sports match is there. Okay. And a team has a winning probability. Okay. So winning probability of, let's say, 0.8. So fine, winning probability is 0.8. So if this is there, then if I ask you what is expectation of it, right? So this will happen once only, right? Nothing will not do again and again. So this is one match. If I ask you what is the expectation, then you can directly tell, okay, so winning probably is 0.8. So expectation of this is also 0.8, or also to call P, right? And if if I ask you what is variance, then you know that variance is like expectation of uh, x square minus expectation of x square, right? So this is how it is. And if you like do this, so this part we know P, right? Expectation of from this, and this is actually again P, right? Uh, because if I give you this thing, let's say this is a random variable, and there is a failure which we denote as 0. There is success which we denote as 1. Okay, this is how we denote random variables. What values a random variable can take, right? So here x is a random variable and it can take 0 or 1. So this is denoting failure, and this is denoting success, right? So in this example, we wanted to win it, right? So winning probability is 1. Winning probability is, sorry, not 1. Winning uh, value of random variable we have taken as 1, right? And probability of that is 0.8. So this will automatically will become 1 minus 0.8, right? Which is 0.2. Okay, so this is probability of x like this. Okay. Now we know that when we wanted to find the expectation, what we do is we take x and we take probability of x and we do the summation, right? So in this case only two are there. So maybe x equal to 0 and p of 1 and probability of x equal to 1. So this is how you'll get expectation, and it will come out that this is 0, right? So this term will go away and you will have only this one, and in that also this is 1. So it will not affect anything, like ultimately you will get p only.
Sir,
Okay.
excuse me, sir.
Yes.
Uh, this is 1 minus 0.8. Oh, this
Yes.
one.
Yes.
Can you please scroll up? Yeah, stop.
Scroll up.
Okay. Okay. Yes, sir.
More.
No, this
Yeah.
sorted match having p is equal to 0. This formula apply, no? This,
Expectation.
yeah,
Yes. So expectation is of a
failure
Bernoulli
and success.
random variable is a p, and variance is p minus p square. So like this it comes, right? So how does it come from? Is like summation of x into px, right? That's how you get the expectation of this. Okay. And
Okay.
then variance of x is, we know that uh we'll do uh x square, we'll find expectation of x square, and we know expectation of x and we square that. So this is how we get the variance, right? So if you do x square of this, so this is x, right? How do you do x square is you you square both of this, right? So 0 and 1. So there is nothing changing here, and probability will not change, right? So it will remain same, right? Like this, right? So if you find expectation of x square, it is also p. So from this we know that this is p, and this is p square, and that's how we get p into 1 minus p also something. So this is expectation and variance of Bernoulli uh, random variable. Okay, so just to uh, tell you that this is only one time we do. Okay, we never do it again or something. Then only it will become a Bernoulli trial. For example, let's say there are uh, there are 40 male are there and 60 female are there in a group. What is the probability of selecting a male? Okay, a male, just one only. Okay, so what is going to be probability of selecting a male?
60 by 100.
60 by 100.
No, male is 40. So
Oh, 40, 40. Yeah. 40 by
Mole.
100.
40
Sorry.
Okay, 40 by
by
100.
100, right? So 40 by 100 is the probability of getting a male, right? So this is a Bernoulli trial. So in which case this is a success and this is a failure,
Failure.
right? So this is how you get this thing, right? So probably now something comes up. This is only once we do, right? So there's nothing much we can talk about, but there is something we can do if we do identical and independent Bernoulli trials. So if we repeat this thing again and again, right? And they have to be independent. So once I did it, doesn't have any impact on the next trial, right? So let's say tossing a coin. I tossed it once, I get head, and if I again toss it, will it affect this? So this tossing will affect it? No, right? There is no effect on my second trial. I can get head or tail. It has equal probability, right? 0.5. If it's a fair coin, it's a there is nothing it will affect, right? Again, if I do, again I do, as many time I can do, but it will not affect my probability. So that's what I mean by independent. So doing event or doing a trial once will not affect my next trial, right? And they are identical in the sense they have equal probability. So probability is not changing. Here probability is 0.5. Again, when I did, again zero probability is 0.5. When I do again, it has 0.5 probability, right? So this is identical and independent trial. For example, let's say rolling a die. Okay, let's say success. My success is getting a 6. Okay, so getting a 6 is my success. Then what is my probability? It is 1 by 6, right? This is my probability. Let's say if I roll die again, if I do it again, uh, will it affect? So once I did it, right? I rolled my die once. Now I'm doing it again. Will it affect any way to my second die, second rolling? No,
No,
right?
sir.
Nothing will get affected. So probability is also 1 by 6, and they are independent, right? Independent. So this is what called independent and identical. So probability is same, and they are independent also, and they are Bernoulli trial because there is success, which is getting 6, and failure is not getting 6, right? So this is a uh, independent and identical, right? Now let's say I have this ball where 4 red balls are there, and let's say 6 blue balls are there, right? This is a task, and I take a ball and I do with replacement. Okay, so with replacement, I am taking a ball out. I noted what is the probability of uh, with replacement. What is the probability of getting a red? Okay, getting a red. And I'm doing replacements. Okay, so so what will happen at first trial? How many? What will be my probability at first trial when I do it once?
4 by 10.
4 by 10, right? Okay. Now at second time,
3
Again
by
when I
4 by
10.
10.
3 by
again
10. Acha, with replacement, sorry.
with
Yeah, 4
replacement,
by
right?
10.
So again 4 by 10, then again 4 by 10, and as many time I can do, it will not change, right? 4 by 10 only because I'm doing with replacement. Now what would have happened if I did it without replacement? right? So if I would have done it without a replacement, now let's say probability of getting a red is at my first trial is
4/10.
4/10. Now what will happen at second trial? If I ask you what will be the probability of getting head at my second trial, or second trial, right? So what will you look for?
3/9.
No. I mean, it's half answer. So first we need to look what happened previously, right? I mean, what happened in the first trial. So let's say if I get red, I mean there are two things, right? Let's say I get red in my first trial or I get blue in my first trial. Then in both the cases it will change, right? And then I have to add them. So if I would have gotten red in my first trial, then how many red left? 3. Total balls have 9, right? If I got blue in my first trial, then it would have
Then
been
4/9.
then 4/9, right? So this two cases can happen, and then I have to sum them up, right? So addition of both. But it doesn't matter. So the point is my probability is changing now, right? So it's not identical. It's not independent also. So this is not IDD. Okay. It's not independent and
IID.
IID. Okay. It's not IID. It's not independent and identical uh, distribution, right? Because now probability is changing. So if this is not happening, so this if this is not the case, or this is the case, or this is the case, or this is the case, then we can use something called binomial random variable. So in binomial random variable, what we do is we should have independent and identical distributed Bernoulli trials. Okay, Bernoulli trials. So make sure that it has to be Bernoulli trials. It can't be anything else. Like let's say something which has three kind of something, right? Let's say success, uh, failure, and maybe draw or something like draw. Then it's not a Bernoulli trial. You can't have it. You only need two cases. Okay, success and failure. It has to be defined. Otherwise, random binomial random variable will not work. Okay. And one more condition is that the trials you do, right? The number of trials has to be finite. Has to be finite. It can be a huge number, like uh, let's say 10,000, 20,000, 30,000, 90,000, lakh, 1 lakh, anything, and is not an issue. Like big number is not an issue. It has to be countable. Okay, so it has to be countable and it has to be finite. Okay, something like this. So if it is infinity, n is equal to infinity, then you can't use binomial random variable. Okay, it has to be something countable. Uh, uh, you'll see, like so you get intuition when we use formula as well, that in formula we use something called permutation combination. So if it is infinity, then you know that permutation combination formula will not work. So that is the intuition. But without there also, like this is the statement, like this how the binomial random variable is defined, that the number of trials has to be finite. Okay, this has to be finite. uh, and in this also, since it's a Bernoulli trials, all the trials are Bernoulli, each individual trial is a Bernoulli, so it will follow all the properties of Bernoulli, that there is success and failure, then um, probability doesn't have to change, right? So independent and identical trial, so probability will not change across each trial, and so on. Okay, so this all properties it has to follow. Okay,
So
now
also the success and failure, the probability of success and failure should also be equally likely.
not equal, it has to be equal.
Equally likely for each case.
Yes, that is what independent and identical, right? So it has to identically also.
No, like
IID case.
for example,
Identically
success
means
have
both
a
both
1/2,
same,
1/2, both cases.
Ye-
Success should also be 1/2 probability, and failure is also 1/2 probability, like this.
Yes, that is okay.
Yeah, it is
That is okay.
necessary. It is compulsory.
No, that is not compulsory. Probability
Also,
has to be let's say first trial something you did, it is the probability is 0.8. Okay.
Hmm.
In second trial,
Oh,
same thing, it has to be there. Third
so
trial,
like in this
0.
case, yeah, okay, understood.
Okay, so this is a
Hmm.
Bernoulli binomial random variable. Okay,
And
it
it
doesn't have
is
to be
the probability
it
of
doesn't have to be
success.
1/2. That is
Okay.
sorry.
And the probability, it is the P is the probability of success.
Yes, that's what we generally take. Yes, P as a probability of success.
Okay.
That's what we consider.
Yes, sir. Understood.
Okay. Okay. So let's say a basket is there. Okay. So in a basketball, and somebody has to throw a basket, right? So this basket he has to throw some anybody. He has a probability that he can throw it in let's say 0.8. Okay, that's what the probability of him making a basket whenever he throws. Like he's a maybe professional. Okay, uh, so yeah. So now if you want to figure it out how. Mm, wait. Question. Yeah. So let's say you want to figure out that uh, what is the probability that he will make three baskets, right? So three he will throw three baskets he will throw. Okay, and he will make out all three of them. That's what the question is. Okay, so uh, this is the probability at which he can throw, and he'll make three throws, and you want to figure out if he can make all three of them, or let's say just one of them. Okay, just to differentiate it, that this thing has no relation with this. Okay, so so first thing is like x or whatever this random variable value can take, it has to be less than equal to so x is always going to be less than equal to n, right? Because this many time you are doing the trial, and in that how many time you are getting a success, right? So that's what x is. Okay, so what can happen? So let's say this is my x. I throw my ball, basketball. Okay, so I didn't get any of them in the basket. Okay, no in the basket. So this is what is represented by 0. One went into the basket, two didn't. Two of them went into the basket, and all three of them uh, are scored as a basket, right? And one more thing I think I didn't mention is throwing this ball is independent of any previous thing, right? So all the throws are independent. Okay, it's not like you threw it, there is more confidence you got, or this player got, and now he will make there's a high chance that he will make it, or he didn't make it, then now he is like frustrated and he couldn't able to make next. So there is no uh, nothing associated with each throw, right? So each throw is an independent case. Okay, so that's when I can use binomial random variable, that probability remains same of each throw. Okay, so each throw has a probability of 0.8. Fine. So what he has to do? So he threw once, right? So uh yeah. So let's say this thing, right? So he has for x equal to 0 case, what he has to do is he should not make a throw, right? And how he couldn't make it is, what is the probability that he will not make a throw? Because I want x equal to
0.2.
0.2, right? And it's independent, right? So another case, is there any dependency? No, right? So I can directly multiply the probabilities. Okay, uh, and so another also he will not make it, and another also he will not make it, right? So this is how I'll get this value. Let's say 0.2 power 3. Okay, now let's say x equal to 1. Now what could happen is he has to make any one throw as a success, right? Any one throw as a basket. So let's say he makes this one as a basket, and or I will write success, and this is failure and failure. Okay, it could happen. Or another case could be, let's say first he couldn't able to, then he could, and then uh, another also he couldn't, right? So this case can happen. Another case could happen is he threw, failed, and then got the success, right? So these three cases could happen. These three cases, but you see that the probability at which all of them are happening is so let's say first one is success, right? So success you'll get at 0.8 probability. Fine. Failure, getting failure is probability of getting failure is
0.2.
0.2.
and then again failure is 0.2, right? Now if you go, let's say this way, like failure, success, failure, then you'll write 0.8 0.2 into 0.8 into 0.2, right? This way. But if you see this both the values are equal, right? There is uh nothing, like just little bit changed in
Interchange
the thing,
position.
right? Position is
Yes, sir.
interchanged, and same will happen here also, right? So what exactly we are doing is we are getting 3 times the 0.2 into square. You can write or if I write 0.8 and 0.2 square, right? So this is what happening, correct? 3 times it can happen uh, if x equal to 1, and this is what happening here. Okay, so same thing if you do with x equal to 2, you'll realize that what is happening is SSF can happen, SFS can happen, or FSS can happen, right? So this is again 3, right? So here the change is that now we are getting 2 times success, right? So the multiplication is like this 0.0.8 into 0.2, right? Like this. So if I write here again, it is like 3 into 0.8 square and then 0.2. Okay,
Yes, sir.
and then 0.2, and then final what is going to be, all of them are failure, all of them are success, sorry, all of them are success, so it is going to be 0.8 power 3.
Hello,
Thank
sir.
you.
Excuse me,
Yes,
sir. 0.8 square. I'm not
yes,
understand.
see 2 times we got the success
Okay.
out of,
Yeah.
right? So how
Yes.
will you
Yes.
do that?
Sir.
One is 0.8, again you got the success,
Yes. Yes.
then you got the failure, right? They are independent,
Yeah.
so you can multiply them, right?
Yes.
Yeah, so that's how we got this all the values. Let's say you wanted to figure out how x equal to 1, right? So this is the answer of our question, that what is the probability that he will make um, one throw, right? Exactly one throw, like that's all. If I would have asked you at least one throw, then it would have been summation of these 3, right? Correct, right? Let's say at least, if the question was at least one throw he has to make, right? So at least one throw. Then what you would have done is e of x equal to 1 can be there, so at least one, right? So one happened. Then probability of x equal to 2 is also there, right? Plus probability of x equal to 3. So this all 3 cases are there, and you have to add them. Or another case, what you can do is you can do 1 minus p of x equal to 0, right? This also you can do. So whenever you see this kind of question, at least one throw, uh, at most something like that. So in this case, let's say at least one throw you see, then you can solve this way also, or easier way is this thing, right? So you if you know this part, the rest of it would have worked out, right? So this you can do. If somebody asks what is the probability of x greater than 2 or greater than equal to 2, anything, right? Greater than 2, then just 3. If greater than equal to 2, then p of x equal to 2 plus p of x equal to 3, right? So uh, just you have to sum this up. So anyway it can be asked, and you can write it. Now comes to the thing. So this all thing we wrote, right? This thing, it can be written as a formula also, and binomial random variable. How does this come with? So what we did first is So this is binomial random variable, and yeah. So how did we get the formula? Is so first we are choosing. Yeah. So let's say probability of x is equal to I, right? So at any point, any value, right? Like we had I equal to 0, 1, 2, and 3 in our case, but it could go up to n if it's a general case, right? So we had this four cases and this. So what we are doing is first we are doing n choose I, right? So we're choosing n out of I. So let's say 0 is a case. I mean when he couldn't able to make any basket, right? There is no basket, he'll make it. Uh, okay, so how will you do this? And or in our case it was 3.
So excuse me, sir.
Yes.
N means success and I means failure.
No. N is total trials.
Okay.
Total trials. These are the uh, I is uh, I is the trials in which you got the success. Okay. Number of success.
Okay.
Okay. So okay. So for when I is equal to 0, like in our case, uh, when we wanted to write I is equal to 0, actually we are looking at all the failures, right? All the failures. All the failures. Failures. Then the number of success is equal to 0, right? That's what we are looking at. Number of success is equal to 0, right? So what we are looking is 3 were there and 3 choose 0. That's what we are looking for. Okay.
Total
Yeah.
numbers of trial 3 and numbers of success 0.
Yeah, number of success 0, right? So this is what we do, but the formula doesn't end here. So n choose I have to do. Then probability means success, right? There is only two
Yeah.
things, either success or failure. So we are looking for probability of I success, right? So this is for how many success you got. That's how the formula is. And this probability is of success, which in our case was 0.8, power I, and multiply by 1 minus p, which is
Power of
0.2, right? And then n minus I. So this many successes you got, let's say 0 you got and 3 failures, then you'll use uh,
3 minus 3 minus 0.
right? So the formula will become n choose 0 into p is 0.8, let's say 0.8 power 0 into 0.2 power 3, right? So 3 minus 0 if you write, then it will become
Yes.
this. So this is what is when you get when you don't get any success, when you get, let's say, one success, right? So then when I is equal to 1, this is for I is equal to 0, this I equal to 1, then what you would have done, I 3 choose 1 multiply by 0.8 power 1 into 0.2 power 2, right? So here it has to be 3. Okay, so like this and so on. So this is what we did here as well. Like we did it directly with our understanding that this is what would have happened if we would have done multiplication of probability, right? Because they are independent, so we can multiply. There's no there's nothing get impacted by what we had
This
in
formula Bernoulli formula, no?
this is binomial random variable.
Yes.
Bernoulli is when we do it once. So if you would have done it once, let's say this basket is there or whatever, you made it once, right? That's all. Then it become Bernoulli. If you do Bernoulli several times, like n times, then it becomes binomial. So binomial is kind of you're repeating same and same thing several times. So it becomes uh binomial. Like yeah, kind like Bernoulli n times, right? That's how you can think that you repeat it Bernoulli trial several times and you get binomial random variable.
Excuse me, sir.
Okay. Yes.
So, what if we consider probability of failure as P and success 1 minus P? Will it make any difference?
will it will not make difference here, but it will make difference in your. I mean, you should know what is it, right? Like the formula wise, it will not affect, but you will get confused if it's being asked. Let's say, what is expectation of x, right? So then it has to be p, right? Which p? Success. So that's what you have to write. Okay. Variance is asked. Oh, sorry. In this case, it's NP. Okay. I will come to this by NP in binomial. Or in this case, it is going to NP into 1 minus p. Okay. So this is what is a variance of x for binomial. So you should know what is success in this case. Like I'm writing p means this is where success probability should go. Okay. It's not like here I'll put it. Otherwise, my solution will come incorrect, right? So yeah, so this all made by thinking that we are thinking about successes in a trial and not the failure. So that's how these formulas all are derived. Okay. Yeah. So okay. So now we will come to expectation of a binomial random variable. So what's happening is there is something called sum of expectation of sum is equal to sum of expectation. Okay, sum of expectation. Uh, I mean, what does it mean? So let's say x or something is a sum of, let's say, x1, x2, x3, x4, something like this, right? You want to figure out what is the expectation of this summation, which you don't know, but you know individual expectation, right? You know the expectation of x1, and you know this expectation, you know this expectation, and you know this also. So like so on. It can go to n, right? So anywhere. So if you know this individual expectations and you sum them up, then you'll get expectation of sum, right? So guess what? We know, right? It's a first is a binomial Bernoulli trial. Right? Each individual trial is a Bernoulli trial, right? And we know the expectation of Bernoulli trial is a p, right? That's what we know. That p is a expectation of a Bernoulli trial. And another next trial again will be a Bernoulli, and it's independent everything. So p, p, and so on. So I'll repeat it till n times, right? N times I'll repeat it, because that's what it means, that I have n trials, uh, and out of them I are successes, and n minus I are failures, right? So this thing I'll repeat n times, and that's how I'll get expectation of my binomial random variable, which is n times p. Okay, n times p is my binomial random variable expectation. Okay, now what is going to be variance? So variance also you can say that like this expectation of sum. In this verse also you can say variance of sum is equal to sum of variance if each trial is independent. Okay, so it's very important that they should be independent. Okay, if trials are independent, then you can do it. Variance of sum is sum of variance if trials are independent. Okay, and in our case it is, so we don't have to worry about that. So each trial is a Bernoulli trial, and the variance of each trial is p into 1 minus p, and second trial will also be the p into 1 minus p, and so on. We'll do n times, right? So this will become n p into 1 minus p. This is how you get variance of binomial random variable. Okay, so this is what binomial random variable is. So like we took example of basket, we can take another example. Let me look into it.
Can you please, sir, scroll down, scroll up, sir? Yeah,
More.
and multiply and
So
p.
no, n is not a multiplication. It's like I'm doing it n times.
So just like written
N times. Huh?
and p
N p. So I'm
multiplication
doing
of
n
1
times,
minus.
right? So how will you add n times?
Okay, okay. Total n times.
Yeah, let's say you have 1 plus 1 plus 1 up to n times, right? Up to n times. How will you add this ones? What is the value you will get?
NP
Uh,
1 minus.
n, right? I mean just one I'm adding. So likewise, if you have p's, let's say, then you would have got np, right?
Yes.
I mean n into 1 was there earlier, then it become n into p.
Sir, can you please scroll up and elaborate me that expectations of sum is equal to sum of expectations once again, please?
So I mean this you can remember that that expectation of a sum, right? Any something is there
Uh, sum
which
does,
form.
sorry, sir.
Sorry.
Does that mean कि individual sums expectation is equal to the expectation sum? I
Yes,
mean,
yes. So
if we are given multiple trials of a, I mean, experiment, and we are
mhm,
adding the individual trials of it and then taking out the expectations of them, that will
mhm.
be equal to the expectations of the individual trials.
No, expectation of all the trials. All the trials. Sum is all the trials. So n trials you did, right? N trials.
Okay. Yes, sir.
This n trials. So each trial we know the expectation. Now if I'm asking what is the expectation of all the trials, so how will you do it? So that's how you do it. So one individual trial you add up all the expectation, and you get it. Okay.
These are Bernoulli trials, right?
Yes, each are Bernoulli trials. So I know Bernoulli trials expectation. I know.
Such expectations are is equal to PS, sir.
In our this is a binomial case, so these are Bernoulli trials. Okay. If later on if it is some other kind of trials, then we have to do that way.
Okay, sir. Thank you.
Okay. So this is binomial case. Now let's say if I give you a question that, let's say, probability of success. Okay, so is, let's say, 0.6. Okay, and you do 4 trials. Okay, 4 trials you do. Then what is the probability of x equal to 2? So this is what, this is a binomial case. So independent, every condition is satisfied. Okay, uh, independent is there, identical is there. Okay, so probability of success is 0. So how will you do this? X equal to 2. That's what you have to figure it out, right? So in our case, when it was I, we did n choose I, then probability of I and 1 minus p power n minus I, right? So that's how we did it. So when it is 2, you will do, how many total trials are there? 4. Out of them, I want 2 to be success, and probability of success is 0.6. So like this, and then 1 minus p is 0.4, and again 2, because n minus I is 2, right? So this is how you will get the answer of this. If it is, let's say, period of x equal to 4, then it would have been 4 choose 4 is 0.6 power 4 and 0.4 power 0, right? So this is how you get it for this. Okay, so any question comes up with binomial, they are easy. Okay, so never miss this kind of question if it's on binomial. because even though you might forget, let's say, formula, you can easily figure it out what you have to do, right? So you have to figure out what all the cases could be possible, and you just have to multiply success and a failure with that power, right? So how many times they are occurring. So let's say 4 time success was there. uh, so I know that power should be 4. Okay.
Excuse me, sir. This
Yes.
0.6,
Yes.
suppose that no, this value. Oh, yes, yes, sir. P is success. Yes, sir.
Yes.
Can this also be calculated by the simple method, like just finding the probabilities of each case and then just putting it?
Correct. Correct. You can do that. Just you need to be careful with this part. Okay. That the same thing is happening multiple times. Like combinations are there. It's not happening one way. There could be multiple ways that the same combination can occur. Right. That's what you have to be careful. That's all.
Yes, sir. But that
Right.
also you also counted in the probability itself, like the
Uh,
cases.
e, no, we didn't. We didn't. See, if uh, let's say this success failure, right? This is the case.
Yes, sir.
Now I didn't write like success failure success, right? This part I didn't do it. I wrote probability of this. So this is going to be 0.6, 0.6, 0.6, and 0.4, right? But
Yes,
this is
sir.
just a one case of it. There will be how many cases? uh
4,
4C3, right? So
3.
this many cases are there, or 4C1, like both are same, so doesn't matter. So this many cases are there, right? 4 cases exactly. So you have to multiply this all thing by 4, which we didn't. Like here we see, uh when we wrote in
That
this,
basket, yes, sir,
we
this one.
actually multiplied by 3 here we don't need to. So, and here
Yes, sir,
also we don't
that's
need.
what I'm saying. The 3 we already multiplied here.
Yeah,
So we
because
already
we
did
knew,
it.
right? Because I calculated manually, and that's how I wrote. But
Yeah.
if you don't want to, you have to use combination. Okay.
So if we make that table like it you did in the basketball example, it would be lengthy. So that's why we are using this formula.
Yes, yes, it will be
Okay.
lengthy. Like, let's say if 3, 4 cases are easy. Let's say 10, the 10 trials happen and choose two something.
Hmm.
I'm like, how many, or let's say 6 happen in this, right? Then choose 6. Now how many ways you will be able to write? Probably few, but not all of them. It will
Hmm.
become very difficult.
Yes, sir.
So you need to use formula somewhere.
Okay, sir. Understood. Yes, sir. Thank you.
Okay. So this was binomial random variable. Now we'll see what is hypergeometric. Uh, okay. Okay. So let's say I have box in which 19 uh, blue balls are there. Okay, so blue, and 6 red balls are there. Okay. If I ask you what is the probability that uh, exactly, okay, so exactly you get 4 blue balls and 1 red ball. Okay, so that's what I'm asking of, right? So can you do that? This is the probability, and okay, so not the conditional one, and so this is the case I'm asking. What is the probability of this, right? So can you do that? uh it's easy, right? So let's say probability is total outcomes by favorable, right? Okay, so what are total outcomes in this? We wanted to uh pick 5 balls, right? That's what these are balls. So let's say 5 balls we want to pick, right? So that is the total outcome out of how many? 25, right? So what is it? 25 C 5, right? So 5 balls I wanted to pick. Now I wanted to pick 4 blue balls, right? So how do you do that? 4 blue balls you want to pick. You can use again combination, right? That uh, we had 19 blue balls. Out of them, I want 4. And so and is there when and is there we multiply, right? 6 out of 6 red balls I want 1, right? So this is what we'll do. And guess what this is? This is actually the hypergeometric random variable. Uh, I mean, in this case, you can mention something as success, like let's say getting blue as success or something
This
like
is
that.
a favorable, no?
Favorable, yes, favorable outcome. This thing. We wanted this case, right? 4 blue balls and one red ball. So total outcomes we want is 5. 5 ball will pick, right? Definitely will pick 5. Then in that 5 only, we wanted to check how 4 has to be blue and 1 has to be red. Okay, any one, like uh red, blue, red, right? So another case could be red, blue, red, and so on. So there are several cases, and any case could happen. Uh, right? And total cases are we will pick 5 balls. So 25 C5. Okay. So
Yes,
so
sir.
this is how you do it, and this is what is hypergeometric random variable. So if you get anywhere like hypergeometric thing, just remember that it's just a use of permutation combination. Otherwise it is difficult. Okay, so understand what is it. It's a little difficult. I'll okay, so yeah. So mhm. Okay, so let's see what is why, but we need this thing, right? Why it didn't work with another, like let's say binomial random variable, or what is the issue with it? So what's happening is we had 19 blue balls and 6 red balls, right? So when I pick, let's say first red ball, it will change the probability, right? Now my trials are not independent because first ball I pegged will be let's say if it is red, right? So if it is red, uh, uh or getting a yeah, okay, see that I like this. The thing could happen is I can get blue ball or I can get red ball. If I get a red blue ball, the probability of getting blue ball is 19 by 25. This is my first trial. Okay, I'm not uh repeating. And another way my first trial could happen is I get a red ball, right? I can get it. That is like 6 by 25. Now, since I already got a blue ball in this case, now how many total balls are left? 24, right? And how many blue balls are left? 18, right? Because I got one. I have one in my hand, and there are 18 left, right? So this will change the probability. So earlier it was 19 by 25. Now it became 18 by 24. If it was blue. Now if I get, let's say, if I want to figure out what is red, getting a red probability, then it is going to be I have total 24 balls, and since in my first I got blue balls, so I have 6 left. So this is like this, right? So you can see the probabilities are changing here, and so I can't use binomial random variable. Something else I have to do, right? Something different I have to do, and that is where this hypergeometric comes up, and actually we did it, like we solved it. Okay, so this is the way it is. Uh, I'll not make it much more difficult. There is a formula of this, which is like, let's say, you can call anything as success. Okay. So let's say if I call blue ball getting a not just blue ball, like uh, okay, yeah. So let's say probability of getting blue ball, right? So this blue ball is my uh, uh is my kind of random variable. Okay, so let's say I denote blue ball as x, and in my trial, which are like limited trials, right? So let's say 5 times I do it, 6 times I do it, right? Something, right? So like that. So uh, some limited number is there, like till n, and it can start from 0, right? 0, 1, 2, 3, and up to n. So what I mean by 0 is then I didn't get my blue ball. Okay, so trials, uh, uh yeah. So how will I write the probability of this x is? What I'm actually doing is, first I did this, I write total outcomes, right? Total is, let's say I had total n kind of things, total n kind of things. Okay, inside n um there were m of one kind, and n minus m left, right? So n minus m of another kind. So in this case, let's say you could be at blue, or this is red or something. I mean, you want to go with the formula, you can do it. So this is how formula is, and then out of m, which are our blue balls, okay, I have to choose some number like 0, 1, 2, 3, 4, or anything, and the rest of them, right? So how many left? N minus m. In that, I'll choose n minus x, right? So this is what hypergeometric random variable uh, distribution is, right? So hypergeometric random variable distribution. You can this is the formula, but instead of formula, you can directly use this thing, right? This is far more easy than the formula. So anything which come up. So what I did is, earlier we solved it for px equal to uh px equal to 4. Okay, so we solved it for px equal to 4 when n was small n was 5 and capital N was 25. Okay, if this is the case you want to solve for, you can use this formula and you'll get it. So let's say 25, and we wanted small m. So small m is uh, small small m is how many blue balls you want, right? So blue balls are 4. uh yeah, small how many total blue balls are there, which are 19. Okay, m is 19, 25 c 19, and this is 19 c4, and this is n 25 minus 19, which is 5, and n minus x, which is 1, right? Now, is it equal to this? uh it doesn't look like, right? Because what
Capital
because
M means,
there is no capital M, capital N is there.
yeah, capital N.
Capital N means uh, total entities, right? So in this case, let's say 16 blue were there, 6 red were there, so 25 total
20,
entities.
25. Yeah.
Yeah. So now, see what answer we got is, we got this answer. Uh, is it equal? Are they both same? This is what we got. Why is there
Both are
6?
same.
Wait. It has to be 6. Okay. This has to be 6, right? Because uh, n minus
Both
m,
are
right?
same
So
value.
both are same, right? Because see here, if you know that 25C19 is equal to 25C5, right? This thing are equal. So that's what difference looks like, but they are same, right? So you can use this formula if you want, but like this understanding this formula is little difficult. Even I feel that. So I generally think this way, that what is the total outcome is there, what is the favorable outcome, and you can directly find the probability of this. Okay, any value you can find it out. Okay, so let's see one example. Let's see. Okay, so let's say deck of 52 card are there. Okay, deck of 52 cards. So draw 5 cards. Okay, so you have to draw 5 cards from the deck. Now you know that. See, there's no question of is it a replacement or without replacement, right? I mean, how will you draw 5 cards with replacement? I mean, at a time, right? So you have to draw all 5 of them together. So there is no way we are doing with replacement, right? So this is of course like without replacement. I mean, sometimes it's not given in the question, but you have to think it, right? That this is of course going to be without replacement. Uh, let's say let random variable x is denoting number of aces in the in the sample of 5, right? So this 5 card we drew, right? So in the random sample of 5 cards, so this 5 cards we drew from the 52 deck card of uh, a deck of 52 card, right? Then what is the probability that uh, then what is the probability that we can give anything will happen with anything you can choose, though, like x equal to 0. Okay, how many first, like number, so this is a random variable of s's, right? How many a's you can expect if I draw 5 cards? So you can see that what can happen is I didn't get any of the s, right? So I picked 5 cards and no card was ace, right? There is a possibility that 1 card could come out as ace, 2 card could come out as ace, 3 and 4, right? Can there be more than 4 aces? No, right? In
No,
deck
sir.
there are 4 aces, right? So these are the values a random variable can take. Now for any of this, you can figure out the value, like you can figure out the probability. So let's say p of x equal to 0, you want to do it, right? So this is the value you want to figure it out. What I'm asking is you pick first, you write total outcomes, right? Which is 52C5. You picked 5 cards, okay? Then out of 4, you should not get any of them, right? On any of the aces. So how we had 4 aces. Out of them, I want to choose none of the aces, right? And how many cards are there left? 48, right? 52 minus 42. All of the cards should be of this, right? Of this 48, right? Then you got this. Let's say you want to figure out what is probability of x equal to 3. Now again, let's say you want to pick 5 cards. that is the trial, like that is the experiment is about. 4 aces total are there. Out of them, you want 3 to be come out, right? So 3 you want to come out, any 3. Like there are 4 kind of this, right? Aces. What do you call diamond? What is it?
Diamond,
Spade,
club,
spade, club, and what is it? What's it?
diamond, club.
Hearts, right? Hearts is there, right? Spade, club, heart, diamond, right? So the 4 kind of there, any 3 can come out, right? Let's say diamond, spade, club can come out, diamond, spade, heart can come out, diamond, I think spade, heart, club can come out, right? So any of them can come out, like this. So 4C3 of them, right? So out of 4, any 3 can come out. Now, out of 48, how many cards I want? 2, right? 2 cards I want out of this 42 to come out. So, or 42, like whatever way to write it, 48C2, right? So this is what a probability of x equal to 3. And any of this probability you can figure it out directly without using this formula. So this formula is there. If you wish to use, you can use it, but without the formula, you can easily solve the question. Okay. So this is how you get the probability of this. You can make probability mass function using this also. Like if you had made it for all of them, you get the probability mass function. Okay. Now, what is the expectation of this? Right. So we know that expectation is summation of p x times probability of x, right? Whatever value it takes, like x is from 0 to n, right? Or it can go, yeah, it can go much than that. So n is the number, right? Highest n, or could be m as well. Anything like so. So this is what it is. Okay, so what is expectation of this? I'm not going to prove this, like how does it comes up, but you can remember it, right? So this is going to be n into m by n. This is what you get as a expectation, and variance of x is, if you want to see the proof, it's done in the video lecture by ma'am. You can watch that, and variance is going to be n into m by n minus m divided by n, uh, n minus n divided by n plus 1. Okay, so this is what a variance of hypergeometric random variable is, and this is expectation. Now there is
Can you
there's
tell
one.
me what does these m and n represent here in the formula?
Oh yeah, sure. So this the m is okay. So n is the object selected from n, right? From n. So if it selects a deck, okay, card deck, then 52 is n, and how many we drew is 5. 5 we drew, right? In our example. So this what it is. Then okay, so in this n, right? So 5 we drew. We wanted some of them as aces, right? 0, 1, 2, 3, 4. You can have this. So whatever you want as success or ace or something, that is m, right? So that is the number of aces. Okay. Okay, out of this n, right? And then whatever left is of course n minus m, right? So I don't need to write that. What else is there? N, m, capital N. Yeah, that's all. Just 3 things are there, right? N is the total, like the sample you took. M is how many S's you want to get, and total in our case is 52. Okay. Yes. Okay. So there is one thing that we are to say is that that when you do binomial trial or you do hypergeometric trial. Okay. Hypergeometric. So what happens is if the sample you took, right? So this is the samples you took, right? 5 of them or something. The sample you took from the pool of, let's say, n, right? So this is the pool, a deck you can say, or anything, if it is related to population or something. If it is too small number, right? If it is very small number, then you will see that uh, you'll see that expectation or anything like a value, right? So a value of a probability of this event is equal to probability of hypergeometry, right? So if both the uh, if taken sample is very small than the total sample, then the probabilities of both of them will be equal, right? Or you can maybe see expectation is also equal in both the cases, right? Or you'll kind of realize that binomial is kind of becoming equal to hypergeometric, or it's other way around actually. Hypergeometric will become almost equal to binomial. Okay. uh Exam point of view, if you see, there is nothing important in this case, like unless it is like specifically else, but like to if you want to do something in like sampling or something, you use statistical way. If you have some experiments you are doing, then you can see that if you are taking too small sample and you want to try hypergeometric trial, then it's better to use binomial itself, right? Because computing hypergeometric is a little bit tedious. Binomial computation is far easier than hypergeometric computation. Okay. Yeah. So this is all about hypergeometric distribution. Uh, you can have this. Yeah. Now, what is Poisson distribution? Okay. This is what we'll cover. So
Um, Sorry, I have a question though.
yeah.
So in the variance, the formula that you wrote, right? It was equivalent to EX into 1 minus P. The first two expression was EX into 1 minus P, right? That is what it translates into. But that last expression, N minus N into
Mhm.
N minus 1, I was not able to fundamentally understand why that was coming in. So in binomial,
Yes. Yes.
yeah,
Yes. Go ahead.
yeah. So in binomial, what we wrote is variance is essentially equal to EX into 1 minus P. That was our expression for the variance, right? In here, it's the same thing except for that last term that's coming in. That is something that is not understanding.
Uh, See, proof you want, you can watch the video and you'll get it, that how does this comes up. Okay, this is just in the proof. Uh,
No,
how will I?
actually, yeah. I mean, I don't want to go into that mathematical proof of it, but intuitively, what is this? When we say a hypergeometric distribution, then what
Hmm.
does this represent? That last term. That's intuitively. I just wanted to understand.
Okay.
Or else, if you can just refer me to some books where possibly this might have explained intuitively, mathematically we can derive it.
It,
But
it is already done in like our video itself. So if you watch ma'am's video, she did it. she explained it. What does it mean?
Okay.
Intuitively as well. She did it. Okay, I'm not. Uh, I'm not going into that, and I kind of forget it. Like, how do I explain it intuitively?
Okay. No problem. I will look into that. Thanks.
Yeah, but she did it. I remember that. Okay. What is Poisson distribution?
Poisson means, sir, just
That's
like
the
name.
name of the person who did it.
Okay,
Like,
okay.
yeah, there is no meaning in name. Okay. No. Okay. So what happens is, like, let's say some event is happening. Okay. Some event happens. Uh, in a like a fixed interval. Okay. Fixed interval. You can consider interval as a, time wise you can consider it, or space wise also. So space means you can say length, volume you can consider. Okay. uh sometimes sometimes space is like not defined, but it is a space, like a page is a space, right? I mean, what is it, like length, volume? But it's nothing like the page of a book, or you know a seat, let's say seat, something you want to decide on that. uh, Space is there, right? So space are there, which we can't figure out, let's say, mathematically. Like length and volume we can do it, but page, what is page? I mean, we don't know, right? Volume wise or length wise, but this is also considered as a space, right? So this thing can come into space. Time is time, like minute, second, and everything will be there. So if an event is happening in a fixed interval, right? uh, right, so then if the question is, what is the probability of that event is happening in in some period of time, right? So that's what is is when the Poisson distribution comes into picture. That uh, so what happens is, we know that some event is happening in this period, uh, about this much time. Then some question is asked that find the probability of uh, it to happen in, let's say, two times or three times or something, right? So we'll see what is that we'll see directly with the example that what I mean by this is, so let's say uh, let's say a store is there. Okay. A store is there. In that, uh, on in an hour. Okay. In an hour, averagely. Okay, averagely 10 customers comes. Okay. 10 customers. uh there is there's one term I use, average. Okay, I didn't say exactly 10 comes. I what I gave you is how much averagely comes up in a store, right? Now, if you want to find out what is the probability that exactly, let's say exactly 10 customers comes in hour. Okay, so I'm giving you time interval, also I'm giving time interval. um right here I'm going time interval, and also I'm saying how many you want to figure it out, right? Like, let's say 10, exactly 10. Another question could be more than 10, right? More than 10 in hour. So again, I'm giving you the time exact, like time is given uh, as given to us in the information, and like more than 10, right? So you know that, let's say, uh, this is this is there, like any kind of distribution you can consider. Like, I'm not using normal distribution and something, right? Let's say, uh, in in average, right, you figure out, let's say in first hour, like this is a hour period, right? So let's say this is a hour, starts from here, and 60 minutes you can consider as a hour, right? Let's say in first 5 minutes 10 comes up, sorry, first 5 minutes 1 comes up, then no one comes up, then 2, 4, 6, and so on, and then you do the experiment several times, and then that's how you get the average, right? That how many average customers are coming in a day, in an hour, right, in an hour. And that's what I'm mentioning here, that you know how many customers are coming averagely in the shop, and you want to figure out how many will come exactly, uh, uh, exactly 10 will come in hour. What is the probability of this is what you want to figure out. Or you want to figure out how more than 10 customer can come in an hour, or another could be less than 10. There's a less than probability of less than 10 in an hour, right? So yeah, averagely 10 comes up, less than this. Now there is one thing that it has nothing to do with this, right? So that I mentioned here, 10 customers averagely comes up, so exactly 10. It could be like exactly, or x, let's say, less than 5 in our, right? Px greater than 5 in our. Now another question could be like p, let's say, probability of x greater than equal to 5 in 2 hour. So this all kind of questions you can solve in using this Poisson distribution. Okay, so what is Poisson distribution? You can say property mass function is, I'll use terms used here. Yeah. Okay, so this, there is something called e power. I'll write the formula and I'll explain what these terms are. Okay, e power minus lambda, lambda power x. So this is x, and this is what x are, right? So this is, here I'm giving you just equal. If you want greater than, less than, then you know that you have to sum up, right? That's how EMF works. And divide by x factorial. X can take values from 0, 1, 2, and it can go up to infinity. So this is the first time I'm telling you that it can go up to infinity. Okay, so earlier we saw binomial. Bernoulli, there is no possibility, but in binomial or in hypergeometric, this random variable can't take a value of infinity. It can take up to a very high number, which we denote as n, but here it can go up to infinity. Okay, uh, so that's how it is. I mean, it looks kind of non-intuitive, that how is it possible that in a shop, in a given interval, infinite number of people will come up. It's not like that, but mathematically it works. Okay, so don't think intuitively that how infinite number of people will come up, but just think that if something like this happens in an interval, infinite things can happen, then how the probability will work. Okay, so it can go up to infinity. Okay, so this is how it is. So what is lambda? Lambda is average given to us, right? So something averagely happens given to us, that averagely this many persons are entering the store, averagely this many mistakes are there in a page, and something, right? So this average is the lambda. Okay, something happened. Let's say car passing by from a road, averagely 30 cars are passing in an hour. So that is what lambda is. Okay, so whatever average is given to you, that is lambda. X is, of course, like figure it out, right? How many numbers you want to go for, like x is 0 to infinity. So and E is you take value is 2.718. It's called Euler's constant, right? Constant. So this is a constant and its value is 2.718. Okay. So this is how you
Oh,
can figure out the
as per the same each pi is just like a value 2 point
same as
pi 3.144.
yeah, pi, yeah. So pi is also constant. So this is another
Yes.
constant, E. Okay, so this is E,
E
constant.
means full form E.
Euler's constant. That Euler's guy was there who find out this constant and its value is this. It also goes, I think, beyond that, but we'll take this. 2.71 is enough. Okay.
Okay.
So let me take an example for this.
Sir, this is the last topic for today.
Yes, correct. This is last. Yeah. So okay, we can solve our thing only. Uh, let's say number of customers entering a store follows the Poisson distribution with a mean. So sometimes average is being mentioned as mean also, right? Mean is average. Mean of, let's say, 10. Okay, 10. Mean number of customers entering a store in an hour. So I would have mentioned in an hour. In an hour follows the Poisson distribution with a mean of 10. Okay, so this is how a question is. Now the find the probability of this x is equal to, let's say, how many customers you want exactly. Let's say 6 in an hour. 6. So in an hour exactly, or if I write find the probability the probability that exactly 6 people enter the store in an hour. Okay, so this is a question. Now the thing given to us is average is given to us, right? So that is lambda, that is 10 in an hour. So time frame is given. Okay, so be careful, that time frame is given is hour, and the question is also exactly 6 people enter the store in an hour. So here see, both the places my time was mentioned here, time was mentioned here, time was mentioned. Interval should be mentioned, okay, because interval will affect your answer. Else I'll take another the next example on that. So how change in interval can affect the answer. Okay. Now if you want to find the probability of x equal to 6, what you have to do is you have to find e power minus lambda power x divided by x factorial, right? So this is what from the formula, and e is constant 2.71 power minus 10 and 10 power 6 divided by 6 factorial. So this is what you'll get as a answer, right?
Minus
Now
means this 2.17 divided upon 10, no? Power.
divided upon 10 power minus 10
Yeah.
power. Yeah, you can write like this also, 1 by 2.71 power 10. I mean, both are same, but uh, see, you will have calculator, so you can easily calculate this. I mean, whatever this value is, but yeah, you can write it anyway. Okay. Now let's say the question is same thing. So lambda is 10, still lambda is 10. Now if I ask how many let's say people entering store, what is the probability that let's say 8 people enters the store in 2 hours, right? So this is what being given to us, that in 2 hours they are asking. What they have given is that averagely or let's say averagely 10 people enters in hour given to us. Now they are asking what will happen if there are 2 hours, right? And probabilities of 8, right? So that's what is given to us. Now see, lambda is you can figure out lambda is how will you do it? So you can do it like in an hour there are 10, so in 2 hours there are going to be 20, right? Like it's easy, like 10 into 2, right? 20 people will enter averagely in 2 hours, right? If I remember, sometimes let's say
Suppose 3 hours, then multiply 3. 30.
multiply by 3. If I recall it, give me a minute. New one. Give me a minute. So I saw it somewhere. I, what is this? Lambda 1 is 10. 10. Lambda 2 is going to be 2 into 10. Yeah. Okay. So you can use this. Okay. So this formula you can use. Fine. So whenever you get different kind of time frames, let's say here 2 hours given, but sometimes what happens is some complicated time frames are given. Let's say how many people will enter in 45 minutes. 45 minutes. How will you do this? I mean, it becomes difficult to compute this, right? So what you can do is, so lambda 1 by lambda 2, you can use this formula and you can do it. So given to us that there are 10 people enters in how much? 60 minutes, right? 60 minutes I can write 1 hour. And they're asking what how many will enter in 45 minutes, right? And this is what I want to figure it out. So lambda 2 is going to be uh, lambda 2 is going to be 10 into 45 divided by 60, right? So you know how to solve this, like cross product, right? So this goes here, this goes there, and you can do it. So 10 into 45 divided by 60, and that's how you got this lambda 2 value. Let's say 45 by 6, right? Whatever. You can do this way. So you can use this thing to solve this problem. That and any kind of ratios are given to us, given to you, you can easily figure it out. But just make sure that uh, how the question is given, how options are given. If sometimes let's say you do this and now it's in minutes, right? So you have to maybe you want to convert it back to hours. It depends, like uh, how does that work? Okay. Yeah. So yeah, correct. Okay, so in our case, let's see how many will enter here into our question was how many will enter, probability of x equal to 2, sorry, x equal to 8, given that time was 2 hours, right? So 2 hours time period was given, and I figured out that lambda is going to be 20, right? Because in hour 10 can go, so 2 hours 20 will go averagely, right? So e power minus lambda, which is 20, lambda, which is 20 power x, and divide by 8 factorial. So this is how you can do it. if it's being asked, probability of x, it's a greater than 8 or greater than 6, right? If this is being asked in t equal to 1 hour, so I'll stick to the time frame given to us. Then how will you do it? So what you have to do is you have to figure out p x equal to, okay, let's say greater than equal to 6. So p equal to x equal to 6 plus p x equal to 7 plus p x equal to 8, right? And so on till p x equal to infinity, right? Because x can go up to infinity. Can you do this? I mean, this summation is not possible. Like there are infinite terms, right? So you can't do that. But what you can do is actually you can do 1 minus p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2, right? This you can do till p of x equal to 6. I mean, x equal to 5. Yeah, let's take x equal to this thing you can do, right? So this 6 terms are there that you can compute, and you can minus subtract it from 1. I mean, this is still uh longer solution, like complicated. But don't worry, like this much will not be asked in any question, like any quiz or anything, because in quiz what can be asked is what is the probability of x greater than equal to 2. This much only can be asked. So what you have to do is p of x 1 minus p of x equal to 0 plus p of x equal to 1. If you do this, you can figure it out. And let's say if we want to do for our case, like what is p of x equal to 0, how will you do is e power lambda is 10 power 0 divided by 10 0 factorial. Okay, so 0 factorial is 1 and this is also 1, so you'll get e power minus 10. And you want to figure out for x equal to 1, that is going to be e power minus 10 power 1 by 1 factorial. So you get e power minus 10 into 10, right? Now p of x greater than equal to 2 is going to be 1 minus e power minus 10 minus e power minus 10 into 10. So, or you can write like this. So this is what you get for this kind of question. So any variation can be asked. Let's say less than 2, greater than 2, 3, anything. You just have to sum it up. Okay, all the probabilities you can sum it up, right? X equal to 0, x equal to 1, x equal to 2, and so on. So as many as you have to sum them up. Okay, nothing new there. So this is what is a hypergeometric random variable, and it's sorry, this is Poisson random variable. And the good part about this is the expectation of this is lambda, and variance of this is also lambda. So if any question is there about expectation and variance, you can directly put whatever lambda is there and you get this. Intuitively, if you see this, like intuition I can give, you can solve this, right? So if you wanted to solve, what you have to do is uh, lambda power x by x factorial, right? Into x and then summation of this, right? From 0 to infinity. So this summation you have to do and you will get lambda. And same thing you have to do, like e power x square minus e power x square, right? So this thing you have to solve and you get lambda. So the solution I'm giving, that lambda is going to be answer. You want I think this expression, this proof is not given in video as well. This proof is somewhat given to you, so you can maybe watch it if you like, but you can directly remember it, that this is what expectation is, this is what variance is of this random variables. And yeah, if somewhere question is asked, you can directly put this. Okay, what is the random, what is going to be expectation of this kind of Poisson distribution, something. Okay, yeah, so let's take another question. Let's say okay, so let's say a typist is there, he makes 1500 mistakes in a book of 500 page. Okay, So here, no, average is not given to us, mean is not given to us, right? So we have to kind of figure it out what is the mean going to be. Okay. These are the mistakes he has done in 500 pages. So 500 is a good enough, you can say, sample or something, right? Now, now what you want to figure it out is what um, that that he'll make no mistake, right? Number of or he'll make no mistakes at all, like p of x equal to 0. This is what you want to figure it out. So what is going to be lambda or um, or mean, right? Uh, Generally it is mean, but be careful, it's not mean always, right? When something frame changes like this, right? So we have to figure out what is how many mistakes he make in a page. So in a page, if I want to figure out, or this x equal to 0 means like uh, no mistakes in a page. Uh, yeah, no mistakes in a page, right? So this is what I want to figure it out. So lambda or mean is going to be, so 1500 mistakes he is making in a 500 pages, right? So 500. This is mistakes pages, and that's how I got lambda value is 3. And I'll use Poisson distribution formula e power minus 3 power 0 mistakes, 0 factorial, and we get this value, right? So this is what we make no mistake in a page. Uh, now if you want no mistake at all, like no mistakes at all, um, or something like all the pages he doesn't make a mistake, right? So we have 500 pages, and on each page he doesn't make mistake. That probability is this e power minus 3, right? So that's how we got, because each page is independent also, right? So there is no way we can directly multiply each page probability, right? E power minus 3 into e power minus 3, so on till, sorry, plus uh, no, it can't be plus. Okay, it has to be plus, right? So I mean, okay, so in one page he can make, he does not make mistake. That probability is e power minus 3, and if he doesn't make mistake in all the pages, then you can directly multiply it with 500 and you get it. Okay. Now we want, let's say, one mistake in a page. How we'll do is, uh, this thing will not change because he makes 3 mistakes, 3 power 1 and 1 factorial, right? So easy, right? E power minus 3 into 3, right? And you want same thing with like all the pages he doesn't make a mistake, or all the pages like number of pages with one mistake only, right? With one mistake. So I mean, like, how accurate he is, like in all the pages he's making one mistake, like one mistake in per page, you can say. Then you can directly do like this, whatever this value is, the 3 into 500. Okay, so this what you can do. And more than 3 greater, you can do it all you have to add, right? Or you can have subtraction of this, right? If question is greater than equal to, let's say, 3, then what you have to do is you have to actually do addition of this, so on, p of x equal to infinite, but we can't do this. So instead what we'll do is 1 minus p of x equal to 0 plus x equal to 1 plus x equal to 2. So this 3 term, if you know, you can figure this out, right? This whole thing. So this is how you can solve any question on Poisson distribution. Okay. Yeah. So that's all for today. Okay. Any questions?
Sir, I have some doubts in extractivity, sir. Can I ask?
Yeah, sure.
Okay, sir, I am sending you the link of the extractivity, which is provided by the instructors.
Excuse me, sir.
Yes.
This slide uploaded, no?
Yes, yes, you will get it. Under live session, this will be there.
Oh, YouTube recorded, not uploaded, no? Slide tabs.
This I wrote. Which one? This one, right?
Yeah,
Yeah,
this
sir.
one PDF.
Yeah, it will be given. Under live session, it will be there.
Sir, I have sent you the link of the activity which is given by the instructors as a sample.
Okay. Yes.
Sir, here, they are using the power play data set, but they told us that not to copy the same data set.
Yes.
Otherwise we will get 0 marks. That's why I have to change my data set, and I have select a football score data set
Okay.
where I
Uh,
have only 500 rows, sir. There is any criteria that I have to choose above 100 rows?
above 100 rows.
That if I choose above 100, it's good, or I have to choose above 1000.
Um, okay. So is it mentioned
Although,
in is it mentioned in this? Like I don't think so. It's mentioned.
hmm,
That how many you want, right? How many
hmm,
rows should be there? Give me a
hmm.
minute. I'll confirm. Give me a minute. I'll confirm.
And sir, something more doubt in the extractivity. At first, you will confirm. Then I
Just sir,
must.
activity and gallery segment. Sorry, practice segment.
Sorry, what activity?
Sir, in extractivity,
Activity,
bro, let me complete. Okay. Sir, he is asking about practice assignment, but I am asking about the extractivity. Sir, can you hear me? Hello? Sir, your microphone is off. Sir, your microphone is off. Unmute yourself. Yeah.
Yeah, wait a minute. Give me a minute, okay?
Open the extractivity. Okay.
yeah, hello. Hello. Hello.
Yes, sir.
Yeah, so your data will work. 500 rows is okay, not an issue.
Okay. Sir,
Yeah,
then open the this one which I have sent again.
you sent again.
Hmm. No, this one which you have opened earlier. This one.
This power play, this thing.
Hmm.
Okay.
Sir, here they are just taking because they have the criteria that they have to choose from the power play. So, they have a limit. they can choose
Hmm.
36 legal deliveries because each over have legal deliveries, and from 20 over there is 6 over of power play in the IPL, which we have
Okay.
known. So they can choose 36 legal deliveries, 6 into 6.
Yes.
But I have choose the football data set,
Okay.
where I have no limit. If I can choose the entire data set. But what I can choose here? Can I choose first 10 matches?
Footwork data set. Fo-
Football. I have chosen football data set.
Football data set. Oh, football data set. Okay. So
Football match data set. Suppose there is some international matches between Portugal, England, Scotland. Suppose that type of matches is there, and
okay.
there is a
So what
there is
is
column
the okay? So
on which I am working that number of goals scored in each matches. Okay.
mm-hmm.
Hmm.
Number of
From this
goals. Okay.
I have to choose. Uh, can I choose that the probability of scoring goals in the first 10 matches?
First 10 matches or n matches. You can have no like goals probability of goals in a n matches. Like let's say 10.
Suppose I am taking it as 10 मैचेस सर देखिए पहले तो ये पहला वाला जो प्रोबेबिलिटी है ना ये तो हमको मैंने 5 गोल तक लिया है उसमें ज्यादा से
हम्म.
ज्यादा एक मैच में 5 गोल नहीं तो अगर मैं जाता जाऊं तो बहुत तक जा सकता हूँ एक मैच में तो
हम्म.
14-15 तक चला जा सकता है लेकिन मैं
Okay.
अपनी कैलकुलेशन की सुविधा के लिए 5 तक लूँ 0 1 2 3 4 5
Okay.
और प्रोबेबिलिटी ऑफ पहले 5 तक निकल लिए 502 मैच है तो
हम्म.
एक मैच में अगर 0 गोल हुए हैं तो 0 का प्रोबेबिलिटी कितना है जितने मैच में 0 गोल हुए बाई 502 ओके
हम्म.
एंड आफ्टर डूइंग ऑल दिस थिंग्स
हम्म.
आई वेंट टू द नेक्स्ट पार्ट ओ सर प्रीवियस स्लाइड
Yeah, no issues. You can talk. क्या कुछ
हाँ
उसमें
आफ्टर दैट where I have to check from the Bernoulli theorem I can't understand. We have to go to the previous slide where
okay, okay, okay. हम्म.
हाँ अब नीचे आइए थोड़ा
Okay.
हाँ मैंने यहाँ तक देख लिया कि कितना क्या करना है तो मैंने
हम्म.
ये लिया है कि फर्स्ट 10 मैचेस में मैं प्रोबेबिलिटी निकालूंगा कि कितने गोल गोल होने की संभावना कितना है
Okay.
तो मैं ये एन की वैल्यू यहाँ तक हो प्रोबेबिलिटी भी मैं निकाल लिया लेकिन ये कैलकुलेशन मुझे समझ नहीं आ रहा पी इक्वल टू हाँ हाँ यहाँ से प्रोबेबिलिटी मुझे समझ नहीं आ रहा सर
ये वाला
हाँ
ये
हाँ इसका कैलकुलेशन मेरे दिमाग में नहीं जा रहा है हाँ हाँ यहाँ से
okay. So
हाँ,
what is success here first? Let's see. Define X number of four occurs in the first 36 legal deliveries of an inning. Okay, number of so okay, so first is like if you see success is uh, putting four, right? Let's say some कोई player है उस four rather वो success है. So 36 means 6 overs में 36 over गिनते हैं. तो how many fours are there, right? So number of success are like this. So इस हिसाब से ये data है. And then they are finding probability that occurrence of four in a ball, right? So all legal delivery.
और मैं यहाँ पे काउंट कर रहा हूँ कि एक मैच में गोल होने की संभावना कितना है ठीक है पांच
हाँ.
फर्स्ट 10 मैचेस में हर एक मैच में गोल होने की संभावना कितना है
Okay.
हम्म तो मैं यहाँ तक आ गया n इक्वल टू 10 लिया 0 to 10
हम्म. Okay.
प्रोबेबिलिटी एक मेरा निकला है इस कैलकुलेशन ऐसे ही कैलकुलेशन किया सेम प्रोसेस में
Okay.
और उसके बाद जो ये p ऑफ x इक्वल टू 0 ये वाला कैलकुलेशन कैसे है मुझे कुछ समझ नहीं आ रहा
X equal to 0 मतलब कि कोई भी गोल नहीं गया, राइट, या इन दिस केस एक भी 4 नहीं गया,
हाँ पहले
राइट।
तक समझ, हाँ यहाँ तक समझ आ गया था, पहले वाला तो इजी है, लेकिन
ओके,
यहाँ पे कैसे निकल रहे हैं इसको? सेकंड सेकंड।
ये
हम्म
पे कैसे निकाल रहे हैं? सो first they figure out what is probability, right? This P, okay? And N is, what is N? N is 36, right? N is 36. See, N is given, right? N 36, P is given. So how will you figure it out? NC 0, P power 0, no, P power 0, yes, and 1 minus P power this thing. So अगर वो multiply करेंगे तो ये आ जाएगा ना?
कैसे सर, एक बार आप दिखाइए, पी एक्स इक्वल टू 0 का कैलकुलेशन कैसे हो रहा है?
Okay, let's see. Let's say what is NC0, which is nothing, 1. Uh, Probability of 0.158. It will not happen at all. And 1 minus this is 0. Hold on, 2, 2, 4, 8, right? 842. So this power 36. What is this? 0.842 power 36 is 0.00204 as, okay, this is how it is. This is how it is.
सर ये आपका कैसे है? 0.4842?
1 minus p, right? So what is binomial formula? NC0 NCI, right? P power I, 1 minus p upon n minus I, n minus I, ऐसा आता है ना फॉर्मूला बाइनोमियल।
ओ अच्छा, एन एन आई
NCI, this is choose NC, let's say NCI
एन
combination.
सी पी पावर आई, अच्छा अच्छा, ओ ये फॉर्मूला हमने पढ़े।
हाँ, जो आज कवर हुआ ये वाला इससे ही आता है।
हाँ आज आज ही कवर किया इसलिए सर याद नहीं आ रहा। सर
हम्म,
वीक 11 का टॉपिक अभी खत्म भी नहीं हुआ और उन्होंने ये डाल दिया है, इसलिए मुझे समझ नहीं आ रहा था कुछ।
वीक 11 आज।
हाँ आज खत्म हुआ है, लेकिन उन्होंने पहले से ही डाल के रखा है, इसलिए समझ नहीं आ रहा था।
ओके ओके,
कौन सा
हम्म
क्वेश्चन है?
क्वेश्चन नहीं है, एक्स्ट्रा एक्टिविटी है।
ओ,
यस यस, सो दिस इज बाइनोमियल डिस्ट्रीब्यूशन, ओके, सो इसलिए ये आता है।
तो सर अगर उसके बाद करें,
हाँ,
उसके बाद अगर करें तो 36 इंटू क्या आएगा
कौन सा?
उसके?
x इक्वल टू 1,
हम्म
क्या बोल रहे हो? एन
हाँ
सी
हाँ
वन
हाँ, NC1, so
जीरो
NC1 is
पॉइंट
n
वन
sir, we know that in
हाँ 36C1, 36n, तो 36 इंटू 0.5 पावर 1, 0.842 पावर 35, ये सॉल्व करने पे आ जाएगा।
इंटू
ये
इंटू 1 माइनस 0.8
4 हाँ वो 1 माइनस पी मैंने कर दिया, 1 माइनस पी इज 0.842।
तो सर एक बार कैलकुलेशन करने दीजिए, ठीक है, देखते हैं। पावर 1
Sir, here
इंटू,
how they are finding the of number of success, probability of success.
सर टू दी पावर 35, 36 माइनस 1 ना। हाँ सर आ रहा
36।
है।
हाँ
आ गया सर। ठीक है सर, ये अब तक क्लियर है। आप और एक बार जाइए सर उस स्लाइड पे। आपको सर बहुत बहुत धन्यवाद सर ये क्लियर करने के लिए। और एक बार जाइए सर।
ओके।
हाँ थोड़ा सा नीचे आ जाइए। सर ये क्या बोल रहे हैं, एक्स ग्रेटर देन 13, 13।
तो ये बोल रहे हैं एक्स ग्रेटर देन 13, अब ये अप्रोक्सीमेटली जीरो जा रहा है, मतलब अगर तुम एक्स इक्वल टू 14 फाइंड करोगे, इक्वल टू 15 फाइंड करोगे, तो ये सब जीरो जाएगा। ठीक है।
और सर ये ग्राफ प्लॉट करना, नीचे वाला।
ये ग्राफ, तुम जो प्रोबेबिलिटी है, तो ये
हम्म
ये प्रोबेबिलिटी है, ये जो एक्स की वैल्यू है, एक्स इक्वल टू 0 पे जो आया उसकी वैल्यू,
हम्म
1 पे जो आया उसकी वैल्यू, 2 पे जो आया उसकी प्रोबेबिलिटी, 3 पे, 4 पे, तो ऐसे करके ये ग्राफ आ जाएगा। ये जो ग्राफ आया ना, ये जो वैल्यूज आई हैं, ये यहाँ पे है, राइट। तो इनको वो करना पड़ेगा ना, ग्राफ बनाने के लिए। तो ये एक्स है और ये उसका वाई है, ये इसको एक्स ले लो, इसको वाई ले लो, ये ग्राफ आ जाएगा, राइट। ये सब एक्स है, ये वाई वैल्यूज है, इधर ऐसे वाई, ये पी ऑफ
अच्छा
एक्स,
अच्छा अच्छा
ये
अच्छा।
एक्स है।
हम्म।
तो ये ग्राफ आ जाएगा ऐसे।
ओ अच्छा, ऐसे ऐसे प्लॉट करना है।
हम्म। ये वैल्यूज मिलने के बाद प्लॉट हो सकता है, राइट। शीट में ये दो लिखो, एक्स वाई, और प्लॉट कर दो, हो जाएगा ऐसे लाइन चार्ट या जो भी है।
लाइन चार्ट ही तो है सर, बार चार्ट तो नहीं है ये।
हाँ लाइन चार्ट ही है, पर ये
हम्म
जो डॉट्स वाला कुछ होता है, डॉटेड लाइन
हम्म।
चार्ट या पता नहीं।
तो सर मैं क्या ऐसा ले सकता हूँ, मैंने जैसे बोला कि पहले 10 मैच में गोल होने की संभावना, ऐसे मैं अपनी एंड से मान के कर सकता हूँ क्या?
हाँ हाँ।
अम, उसमें मुझे मार्क्स मिलेगा?
यस। तो ऐसे मतलब ये पूरा बनाना कि क्या सक्सेस है, व्हाट इज ट्रायल, ट्रायल में सक्सेस क्या है वो मेंशन करो। जैसे लेट पी बी द प्रोबेबिलिटी ऑफ सक्सेस, राइट। सो पी इज अकरेंस ऑफ 4 इन अ बॉल।
हम्म।
तो तुम्हारा क्या है, अकरेंस ऑफ गोल इन अ मैच, और इन अ मैच ऑफ 10, ऐसे अकरेंस ऑफ गोल इन 10 मैचेस। तो ये तुम्हारा प्रोबेबिलिटी ऑफ सक्सेस हो जाएगा। तो वो कैसे डिफाइन करोगे, उस हिसाब से तुम्हें फिर नेक्स्ट लिखना पड़ेगा। सो ये पार्ट अगर तुम सही से डिफाइन करोगे तो बाकी सब हो जाएगा। ओके।
सर यहाँ पे प्रोबेबिलिटी ऑफ सक्सेस फाइंड करने के लिए सैंपल स्पेस में 36 से क्यों इनटू किया गया है?
36 ही क्यों लिया गया है?
नहीं सर,
आ,
सैंपल टोटल आउटकम्स में यहाँ पे 36 से क्यों इनटू किया गया है 1598 के साथ?
36 क्योंकि एक ओवर में 6 डिलीवरीज, लीगल डिलीवरीज होती है। एक ओवर में 6 गेंदे आप डाल सकते हैं। तो
यस
पावर प्ले होता है 6 ओवर का, तो 6 × 6
यस
36।
ओके
यस।
सर।
और लेकिन सर हम फुटबॉल में तो ऐसे कोई लिमिट नहीं है ओवर्स की, उसमें तो 90 मिनट का खेल है।
तो तुम कुछ डिजाइन जैसे कर दो ना, डिफाइन कर दो कि
हाँ सर, मैंने एक्स को ऐसे किया है कि मैं बोलता हूँ मैं क्या किया। नंबर ऑफ टाइम्स गोल्स स्कोर्ड इन फर्स्ट 10 मैचेस।
फर्स्ट 10 मैचेस, हाँ बस तो चल जाएगा।
हाँ, नंबर ऑफ
बट
टाइम्स गोल्स स्कोर्ड इन फर्स्ट 10 मैचेस, बस इतना ही लिखा है डिफाइन को एक्स का।
फर्स्ट 10 मैचेस,
हम्म
और कितने मैचेस तक, कितने 10 मैचेस तक जाएगा ये? आई
फर्स्ट
मीन
10, फर्स्ट 10 मैच।
नहीं, फर्स्ट 10, ओके, फर्स्ट 10 मैचेस, ओके ओके फाइन। सो n इज इक्वल टू 10, राइट?
हाँ हाँ हाँ, तो वैसे ही मैं निकल रहा हूँ, लेकिन सर मेरा 3 डेसिमल प्लेस तक आ रहा है ऑटोमेटिक गूगल शीट पे।
ओके, नो इश्यूज।
यहाँ पे 4 डेसिमल प्लेस तक लिया है, लेकिन मेरा गूगल शीट
नहीं नहीं,
मुझे
वो 4 डेसिमल की वो बात नहीं है, वो जितना आता है उतना ही लिखो, कोई दिक्कत नहीं है। तुम्हारे बस करेक्ट होना चाहिए कि तुमने जो करा है वो, मतलब काउंटिंग इतना इतना इश्यू नहीं है, वो 4 डेसिमल 3 डेसिमल, बस ये है कि तुमने
हाँ,
सही से वो करा है
काउंटिंग
कि
थोड़ा
नहीं।
ऊपर नीचे होगा तो वैसे कोई दिक्कत नहीं होगा।
हाँ, वो इतना इश्यू नहीं है, बट इस सक्सेस तुम जो डिफाइन कर रहे हो वो बहुत इंपॉर्टेंट है, ये वाला पार्ट बस। ये
हम्म।
क्या है और इससे वो समझ आना चाहिए जैसे भी तुम डिफाइन करो,
अच्छा अच्छा।
है ना? तुम जो पीयर जो रिव्यू करेगा उसको ये सक्सेस वाला पार्ट समझ आना चाहिए।
ओके ओके ओके।
ओके ओके, नेक्स्ट, एनीथिंग एल्स?
सर
एक्स्ट्रा एक्टिविटी,
एक्टिव
अच्छा, व्हाट इज क्वेश्चन? सॉरी, no, some activity question, right? uh, Anything else?
सर
Huh?
एक्टिविटी 11.3 के क्वेश्चन 5th में डाउट है।
Okay. So activity 3.1.
यस सर, क्वेश्चन 5th।
uh for suppose 4.5% of people living in particular city own a Creta. Survey has been conducted to know that what brand of cars people use in the city was probably the 12th person being interviewed during the is the second one to own Creta. Which 4.5% people, what brand of car people use in city? Probably the 12th person being interviewed during the survey. The second one is the second one to own Creta. Okay, so okay, so क्या फाइंड करना हमें हमें करना है? So we need to find out that he has to be second out of 12th person being interviewed, right? So x equal to 2 when n is equal to 12, right? This is what that is, that you interview 12 people, okay, 12 people, and the and out of 12, uh, okay, so it's like this, that let's say first person is there who owns something, anything, let's say second person owns Creta, then anything, like let's say I'll let a a a and so on till 11th one, and then the 12th one, no, what is probably the 12th person being interviewed during survey is the second one to own Creta. So he has to own Creta, right? So this guy has to own Creta second month, and this like this. Yes. So how many went through? 4.5. Okay. Now what could happen is, like, first we need to figure out how this could happen, right? So let's say 11. First, let's see what are 11 people. Okay, 11 people are there. Anyone can own Creta. Anyone. Okay, anyone can own Creta, and rest of them have to own something else, right? So can I figure out this probability? Probability of owning x equal to 1. Can I do this?
Yes, sir.
Yes, right. So 4.5 is the success, right? So what I have to do is 11C1, right? Success is 0.4 or 4.5. Given to us 4.5. 4.5%. Okay, so percent I have to convert in probability, right? So probability is going to be 4.5 divided by 100. Yes, if it is going to be 100, then 1. 4. So this is going to be 0.045, right? This is what P is. Okay, so this is 0.045 power 1, and you have to do 1 minus this power 11. So this is what you will get probability of 11 guy, right? So x equal to 1 means 11th guy you entered and you got this probability. But there is another guy, 12th one. He has to own the Creta, right? He has to own the Creta. And what is the probability of that? That is like independent event, right? So you can directly multiply with 0.045. If you do this, you will get the answer. Okay. So 12th person
Yes,
has to own it, and 11 you have to figure it out.
sir. Week 10 graded assignment का question 1 and 2.
Graded assignment.
Yes, sir.
Okay.
What is the deadline of graded assignment? In my portal, it's showing that the deadline is on 18th.
Of 11th.
11th का 18 शो हो रहा है सर.
Yeah, that is the grade line. Whatever it's mentioned, 18th.
Oh, you are 18th. But the rest of the subjects are showing that it's on 11th. Maths का city, they are showing that they are on 11th. What?
Is it? So wait.
So
Uh,
the सर ये
that-
ठीक ठाक तो है ना? बाद में चेंज फंज हो जाएगा तो.
wait. I think you are right. It's mentioned in this. What? Get this. Guideline document or something is given, right? Grading document. Yeah, it's mentioned in grading document. Week 11 foundation deadline is 11th. Yeah, that is correct. It has to be 11th, not 18th. Yeah, it has to be 11th. But okay, I'll send announcement if there is, it's going to be 18th. I'll send announcement. But
सर
it has to
अगर
be in 11th.
सर अगर 18 में हो जाए ना तो बढ़िया होगा क्योंकि सर ये एक्स्ट्रा एक्टिविटी वगैरह बहुत सारी चीज़ें हैं इस वीक में.
Okay, okay.
तो 18 को कर दीजिए सर आप
Okay,
अगर पॉसिबल होता है तो.
okay. We'll try. I'll confirm and try. Okay, graded assignment. Which question?
Question 1 and 2.
1 and 2. There are 2% numbered cards in deck. Here's the number. This. Solution is uploaded? No.
सर मैंने
Just
चेक नहीं किया.
just checking. Okay, you already checked. Two power 7 numbered cards in a deck, among which 7C card be at this number. This from the deck, 11 cards are drawn with replacement. What is the expectation of some of their numbers? The expectation is asked. So 7C card would be a number. What's the expectation of sum of the sum of their numbers? Um, so 3. So we have 0, 1, 2, and till 7. But they are asked. But 11 cards are drawn with replacement. Uh, uh, 7. Expectation of sum of their numbers.
Sir, some can be 9 also, na? If we take
Yeah, some could be. Yeah, some can be actually till. It can be anything. 11 cards are drawn with replacement. Okay, with replacement, they are drawing the cards. Um, 7CI. So they are saying 7C0, which is 7, 7C1, 7C2 is going, 7C0 is 1. Seven, then 7 into 6 by 2 is 21. So on. So it's like that till 1, right? Uh, okay. Z is okay. And 11. Not sure. Um, Cards are drawn. Replacement 11. Zero, 7. 2 power 7. Power. Okay. So this is 2 power 7. Okay. So okay, so the thing is, okay, it's there. Hello, hello, hello. Oh, he left. He really left.